Good afternoon. I'm Siva Kumar from the Department of Electrical Engineering, IIT Hyderabad. So my area of interest is power electronics. Definitely, it is very hard to talk after the big, the renowned professors. So that's why I'm not going to go into a very generalized thing. I try to put my boundaries within the area of power electronics, and I will try to see. At least I'll show what I did it. So I try to put it very friendly. So what the power electronics and why it is so important and why it has to be given to the student. It is like this. I am going to start with a very small story. Just like although like I have a new thing. As sometime back you have a king and you have a people. The king will decide the rules and the people have to follow. If somebody don't want to follow, he has to leave the country. There is no other option. Similarly, the Greeks for some time back, you have a 58 and 230 volts, and every load has to be designed for that. So otherwise the loads cannot compatible. There will be a compatibility. You only have some other generation system that also should come with 230 and 58. So that was the system which has come up. Presently, because of the needs of the power, and similarly the loads, which has been tremendously changed. The loads are completely undisciplined. If I want to say, they are not going to. They require 3 volts or 1.8 volts to all the way to some kilovolts. And the generation also will be there all the way from millivolts and microvolts, where the micro people from microwatts and milliwatts to few megawatts. So there the importance of power electronics comes here, where we are going to convert whichever the form available energy sources, whichever the compatible to the load. So entire box is going to fit out here. So as I want to bring out some of the points. So the olden days, the prehistory of the power electronics, where you have the mercury and the vacuum tube rectifier. And of course, we are not going to study all those things at this point of time. Many of you know it, and I also we never studied. So where the thyristors and then the diode, thyristors and fully controlled semiconductor device, GPO, GPRs and power MOSFET. And now we are at the era of IGBT and power MOSFET, where we can switch all the way to some hundreds of megahertz, or at least some tens of, hundreds of kilohertz, where are tens of kilohertz for a high power levels. So what I feel that I think we have to more concentrate here. At least I am doing it instead of saying it. We are concentrating on more on recent trends and all those things. On top of it, like I pointed some of the things which I am doing it or were listed the other foreigners sometimes. So which I am trying to do. These are the 4 things which we can do anything in the power electronics, either AC to DC or DC to DC or DC to AC or AC to AC. So any converter if we take, one of them will be fitted into these 4 categories. How we are implementing is something different. So at least before introducing the student, directly saying that this is a converter of this and all those things. So just we can start with the importance of the converter and then you introduce this. This is the requirement and just we can introduce it. And introduce the converters very from the basic. It is not like directly putting on a board, okay, this is your converter and this is the input and this is the output. Saying that how can you ever assume that we have a single safe switch and do it and try to build from very basic thing which we don't have anything. And showing animations, because today we have all MATLAB and many animations which is available in the net also, so software. Showing animations, analyzing the converter output waveforms using graphical way. Sometimes we will go seriously in the mathematics, sometimes we can show it in a graphical way also, which will help the students will get more attracted for that. And many a times we are going to more concentrate on the converter side, where how to integrate the controller versus the inverter or converter. The bridge is also very important. Where I have seen that sometimes for few months I worked in the industry, there also it is most important is that how we are going to bridge our the converters part versus the controller. There is a gate drivers and why isolation is required and many things. Introducing available power electronic switches in the real market. The present situation, what are the switches and with the data sheets. And motivating the students to build a basic converter. I can say that at least I tried for last 2 years. So I can say that my response is very good. And they have done, I deliberately took the very bad ones. I didn't have good ones also, I'm going to show it. So this is a kind of voltage learner circuit which we are going to teach in the classroom. It should not cost more than 50 rupees altogether. But after building this by a student, his confidence level is very high. And this is like not this actually. linear voltage regulator. This is also not cost more than 50 rupees. Once he has this, he will not to depend on the existing power supplies or where the lab has to buy it and all those things. We will not believe once it has been done, and it will be with him for his entire course. And whenever he wants a voltage, he can feel that this is my product. He is going to use wherever he wants it, this 5 volts. So you have to depend on the lab resources or something. Only the thing is that you have to provide a component. As we know that this component is not more than 10 rupees or 50 rupees. And this is a buck converter who made it. The slowly the progress. Like I am giving for the maximum number of students where you can do very basics, and this is a buck converter. Buck converter. So with this, no, they have a feel. Like even if I go there and touch or something is going to happen. So they will have more affectionate to it. And when they are going to observe the voltage at one level to one level, like every place, they can have access to measure at each diode, each capacitor or something. They have been more excited. On top of it, they have come across, this is an inverter leg, one inverter leg. So with this, they can do any kind of experiment. They can duplicate this and make a 3-level inverter, multi-level inverter, or buck converter, any converter in the power electronics, they can do with this. So where the gate drivers and control deadband circuits and power supplies for that, everything which has been fitted. Although I am showing that it is not clean. So all these things were not more than 100 or 200 rupees. At the end of the day, some of the students came into an interest and they made like a board like with the PCB. It cost me 110 rupees the board to make because I made it only 3 boards. If I go for a higher number, now I am going to get it for 30 rupees or 40 rupees board. So what I am trying to say that nowadays we are not see. I have not done that. The students within this has done in 2 years. What I am trying to say because I have not started a long time back. So this is at power level they have done. This can handle around 600 volts and 25 amperes. So this has not costed me 150 rupees or 200 rupees. So what we can see that like instead of giving a modules and trying to do it like the knob rotating and all those things, if this has been done, the students are more encouraged. As like once I was sitting with the Professor Koyatulai lecture, or whatever send off he has given to us. When I was here, he said that at least the PhD student get first paper in a year, right? That's what I got it. So where now I have 5 PhD students. Out of the 5, 4 got the paper in first year. I didn't do much. The only thing is that I spent one complete day with them. Every day I was going with them. And like what they did it, I am trying to give my inputs. And whatever, like they will come with crazy ideas and I am going to sit with a crazy and something worked out. All of them like almost out of 5, 4 has a paper. The 5th one also has an idea, but he has a like ANSYS software, recently we bought it and is working on. So at least for me it worked because I gave this kind of hands-on experiment and they have been excited, they are coming back every time and at least it worked me. So instead of giving a suggestion, I am trying to put from my side what I did and it worked. And even at Purdue University I have seen, they also have this kind of things, but not at this very bad condition. They have a prototype and associated with breadboard. And every lead will be given to one of the microcontroller lead or whatever. So student will be given with that kit and you can access all the points within the microcontroller or embedded system or whatever. And they can build their own. So if we have money, we can go with that. If we don't have money, we have a constraint, we can go with it. Only we have to make sure that sometimes people will burn some of the ICs. Yeah, we have to be really careful. And end of the day, sometimes, whenever like at least very few times within 2 years, I visited 5-10 colleges. They say that buying inverters and all those things will be costlier situation. But I am completely against for that. So we have seen like here, you can see, this inverter came to me for 18,000 rupees. The each IGBT module which is sitting here, which can handle around 1200 volts and 300 amperes. Which cost me around 4,500 rupees of each module, 4 modules together. On top of this is a gate driver which is designed in the CEDT, not here, IIT. And our students also doing it. Maybe by next semester we will be ready with our own gate driver. So what I am trying to say is that we can build our own thing. Sometimes people say that production all those things, but even directly give a power supply is not going to last. We can see that 200 volts and 300 amperes. Because we have our control. So I feel the students we can give this kind of motivation where they can get more interest and they can do it in a right direction. Thank you.